I recently cut 2 seconds off of a production endpoint, and I did this without making the code itself any faster. The trick? I moved one slow operation into a Hangfire background job. In this video, I'll show you how to set up Hangfire, explain how Hangfire actually works. We'll walk through each of the 4 main job types, see how to use automatic retries, and finally, we'll wrap everything up with Hangfire's best feature, its dashboard. I'm a principal software engineer with over 10 years experience, and I work at one of the largest US payment processors. I personally use Hangfire in real-world production systems to handle email sending, file processing, and external API calls, and it's running on my own site, gamingseas.com, right now. Let's get started by installing and setting up Hangfire. Everything I build in this video is on GitHub as a runnable sample app, so you can follow along or grab the finished code. The link is in the description. First, let's install the required NuGet packages. At a minimum, you'll need Hangfire.ASP.NET Core and a storage provider. In this video, we'll use SQL Server, so we will install Hangfire SQL Server. If you're on Postgres, you'll just swap out the second package for Hangfire.PostgreSQL. The setup is largely the same regardless of which storage engine you choose. The important idea is that Hangfire stores jobs in a persistent data store rather than in memory. We'll see why that matters in a moment. For this tutorial, I'm running SQL Server in a Docker container. If you would like a walkthrough of containerizing a .NET app with SQL Server, I've got a dedicated video linked in the description. Now let's set up Hangfire in our program.cs. We call add Hangfire and point it at SQL Server using a connection string called Hangfire connection. I'm passing one storage option, queue poll interval, set to 1 second, purely so jobs start instantly for the camera. The default is 15 seconds, and that default is absolutely fine in production. And that connection string lives in our app settings.json under connection strings. Next, we start the Hangfire processing server with add Hangfire server. This is the piece that actually does the work. It starts a pool of background worker threads inside our app that watch the database and run jobs. I'm lowering its schedule polling to 1 second. Same reason as before, so delayed jobs and retries fire promptly whilst we watch in this demo. Finally, we call use Hangfire dashboard to enable Hangfire's built-in dashboard. With that, Hangfire is fully configured and ready to start processing jobs. Okay, let's run the app and see what happens to our database. I haven't written a single database migration. Hangfire has itself created its own tables automatically. This is where every job, its state, and its history will live. And if I navigate to /Hangfire, we will see the Hangfire dashboard. Every job that we run or schedule will show up here. Next, let's take a step back and look at how Hangfire actually works under the hood. At its core, Hangfire is a persistent background job queue. Your application adds jobs to the queue, and background workers pick up those jobs and execute them. That's the core idea. Everything else in Hangfire, retries, scheduling, and the dashboard all build on that idea. So what does this actually mean? So first, what's a queue? A queue is a data structure where items are processed in the order they arrive. First in, first out. Just like a queue at a coffee shop. The worker always processes the job at the front of the queue first. So how does that job get into the queue? You enqueue it like this. This tells Hangfire to run the send welcome email method in the background. So what actually happens when you make that call? Hangfire breaks that job down into data that describes what should happen, which class to use, which method to call, and what arguments to pass into it. That description is then saved in the database as JSON. Because the job is persisted in a database, that queue survives application restarts and crashes. This is one of the major benefits to Hangfire over simple in-memory background tasks that disappear if your application ever stops. Meanwhile, on the other side, we have the Hangfire server. It continuously polls the database looking for jobs. Polling simply means to repeatedly check. So conceptually, it looks like this. When a worker finds a job, it pulls the job from the queue and executes the method that the job describes. Hangfire then records the result of that method execution in the database. Put the whole flow together and it looks like this. In this flow, we have the Hangfire client, which enqueues background jobs and stores them in the database. The Hangfire server retrieves the jobs from the database and executes them. Unless you have a very complex setup, the client and the server lives in the same application. Now, let's look at the 4 core Hangfire job types. First up, fire and forget jobs. A fire and forget job runs as soon as possible in the background. Your application enqueues the job and immediately continues processing the request without waiting for the job to complete. When a user registers on gamingseeds.com, the application needs to send a confirmation email. Sending that email means a call out to a third-party email API and waiting for its response. With a cold connection, that can take a few seconds. There is no reason to block that user's registration while waiting for that API call. Our demo app shows this exact use case. The registration endpoint awaits the email send-in line during the registration request. And that's the same pattern that was costing me 2 seconds in production. So let's fix it. Instead of awaiting the send, we queue a background job. The email sending class already exists in the skeleton. It's what the inline endpoint calls. All we do is put an interface in front of it. So let's create an email job interface with the send confirmation email method that takes a user ID. Now we update the email job class to implement that interface. And then update the registration in program.cs to bind the interface. Then we will add a second registration endpoint. We'll keep the old inline endpoint around so we can race the two in a moment. We no longer pass in the email job class directly. Instead, we'll pass in an background job client. This will allow us to enqueue the job rather than calling it directly. Our new endpoint stays pretty much the same as before. Save the user, but instead of awaiting the send, we enqueue it. We're not actually calling the method here. We're handing Hangfire a description of the method that we want to run in the background. Let's see the difference. Old way first, inline send. We click and we wait and we wait. There it is, 2000 milliseconds. Now the Hangfire version. Click, a few dozen milliseconds, the response is back before you can blink. Quick question before we move on. What's the slowest thing in your request pipeline right now? A confirmation email, a PDF export, a call out to some third-party API? Drop it in the comments. Chances are it's the perfect fire and forget candidate, and it'll help me tailor future videos. Job type 2, delayed jobs. A delayed job is scheduled to run at a specific time in the future. Instead of executing immediately, Hangfire stores the job and waits until a set time before executing it. Delayed jobs are useful for reminders, follow-ups, and time-based workflows. As you know, on Gaming Seeds, when a user registers, they receive a confirmation email. But sometimes users don't confirm their email address. Gaming Seeds schedules a reminder email that is sent 24 hours later if the user has not confirmed their account. We're back in the same registration endpoint. One more line right under the enqueue. The code is almost identical as the fire and forget job. We call schedule instead of enqueue and pass a delay. Same interface, same job client, one extra argument. I'm pulling the delay here from config. In production, it's 24 hours, but in this demo, it's 30 seconds so we can actually watch it fire. And here's the reminder itself. Before anything else, it checks whether the user is already confirmed. And if they have, it simply returns and does nothing. This is important because we do not want to be sending reminders to users that have already registered. I'll now register 2 users and confirm just one of them. Over in the dashboard scheduled tab, both reminders are sitting there. Give it a moment, refresh, and they're gone from scheduled. Now look at the outbox. One reminder for the user who forgot to confirm their registration. The confirmed user's job still ran, it just quietly did nothing. Job type 3, reoccurring jobs. A recurring job runs on a schedule. Instead of running once, the job runs repeatedly according to a defined schedule. You'll reach for these for maintenance and scheduled system work, such as clearing temporary data, processing reports, and synchronizing with external systems. When users register on Gaming Seeds, they're expected to confirm their email address. If they never confirm, those accounts become inactive clutter in the database. Gaming Seeds runs a daily job that deletes accounts that have not confirmed within 7 days. Reoccurring jobs belong in the application, not a request. So this time we're going to work in the program.cs at startup. For reoccurring jobs, we use add or update on the iReoccurring job manager, the reoccurring counterpart to the iBackground job client, which I'm grabbing from the container at startup. We'll give it a stable ID, clean up unconfirmed users, the method to run, and a schedule. Because it's keyed on that ID, running this on every deploy or startup just updates the same schedule instead of piling up duplicates. I'll seed a few abandoned accounts now, 30 days old, never confirmed. Normally, this job runs in the early hours of the morning, but I don't want to wait, so in the recurring tab, I'll just hit trigger now. Watch the users panel, and there they go. And now the final job type, continuations. Continuation jobs run only after another job finishes successfully. This allows you to build workflows where one background task triggers the next. Imagine a user uploads a screenshot for a Minecraft seed. Processing that image might involve multiple steps. Each step depends on the previous one completing successfully. Exactly the chain continuations give us. We enqueue the first job, process the image. Exactly as before. But now enqueue hands us back a job ID. We pass that ID into continue job with to schedule the thumbnail step, which gives us another ID. And we chain the optimize step off of that one. Each call links to the one before it. Watch what happens when I upload an image. The pipeline fills in left to right, process first, then the thumbnail, then the optimized version. Each step only starts after the one before it succeeds. And over in the dashboard, while the first job is running, the other 2 are sitting in a state called awaiting, literally parked, waiting for their parent to finish. If any step had thrown an exception, the rest of the chain simply wouldn't run. One of Hangfire's headline features is that it retries failed jobs automatically. So far, every job we've ran has ran successfully, but in the real world, jobs fail. If a job throws an exception, Hangfire doesn't just give up. By default, it will retry the job up to 10 times, with an increasing back-off delay between attempts. You can tune this per job with the automatic retries attribute. Here's a job that calls a flaky external API. I want it to retry 3 times before giving up, with a short, growing back-off. 3, 6, then 9 seconds. Because we enqueue through the interface, Hangfire reads the attribute from the interface, not the implementation. If you put the automatic retry attribute on the class, it will be silently ignored and you will fall back to the default 10 retries. This one catches people out. I've given the demo app a little toggle that simulates a third-party API being down. The job froze. And notice Hangfire doesn't just drop it. It waits 3 seconds, tries again. Still down, tries again. And only after every attempt has failed does it land in the failed state. Even then, it's not gone. I can open it and read the exact exception and the stack trace. Everything I would need on a 2 AM callout. We've been glancing at this dashboard all video. Every job we ran showed up in it. Now let's give it the tour it deserves, because it's one of Hangfire's most powerful features. This visibility is extremely valuable in production systems because you can immediately see when tasks fail. Let me give you the full tour. Every state we've met in this video has its own tab. Succeeded jobs, anything currently processing, scheduled jobs waiting for their due time, continuations sitting awaiting, your reoccurring jobs with their next runtime, the retry queue, and failed jobs with their exceptions. Click into any job and you'll get the arguments, the timeline, and the full history. You get all of this for free without writing a single line of code. One last thing before we wrap up, security. Remember, the whole dashboard was enabled with that one line, that one use Hangfire dashboard call. Locally, this is fine. But the moment you want to reach it from anywhere else, a production server, you need to implement an iDashboard authorization filter and put real authentication in front of it. Never expose an unauthenticated dashboard to the internet. And that's Hangfire. In this video, we've covered how to set up Hangfire in a .NET application, how it works internally as a persistent job queue, the 4 job types, and how to monitor everything using the Hangfire dashboard. The key takeaway is that Hangfire lets you move slow or non-critical work out of your request pipeline and process it reliably in the background. This keeps your application fast, reliant, and much easier to scale. If you are building real-world .NET applications, background jobs are something you will almost certainly need at some point, and Hangfire is one of the most battle-tested tools available. The full sample app is on GitHub and linked in the description. If you want to see some of these ideas in action, check out gamingseeds.com, my community website where players share and discover Minecraft seeds. Several of the examples in this video, like email confirmation and account cleanup jobs, are running there right now using Hangfire. If you found this video helpful, consider subscribing for more deep dives into .NET architecture, backend systems, and real-world engineering practices. Thank you for watching, and I'll see you in the next one.